Hey brilliant minds, welcome back to part 3 of the video where we look at the last two questions of the past paper questions, okay? Because remember, the aim is not only to get through the question but to thoroughly understand how we get to the correct solution, right? So on the last two videos, we looked at 4.1 up to 4.4. If you missed that, please go back and catch up on that. Now here we only left with 4.5 and 4.6. 4.5 says, determine the equation of the axis of symmetry of which G has a positive gradient. Right. So now, let's just go to page where we're going to look at that. Now, the hyperbola, so the general formula of a hyperbola is y a over x minus p plus q. Our axis of symmetry is made up of two lines, right? The one with a positive gradient, and the one with a negative gradient. So for the positive gradient one, this is given by y is equals to this and that, which then will be x minus p plus q. The negative gradient one, it's still y is equals to now negative x minus p plus q. So the negative gradient part occurs when we put the negative outside our x minus p, or outside the vertical asymptote. Okay, so the question specifically asks for the axis of symmetry with the positive gradient, which means this is our interest. So we have g of x as 1 over x minus 1 plus a 2, meaning our line of axis of symmetry with the positive gradient will be x minus 1, okay? So we take the bottom part and our q there, plus 2. This will then be x plus 1. That is our answer for 4.5, the axis of symmetry with a positive gradient. Okay. 4.6, write down the domain of H if H of x is G of x with a transformation, right? So H of x is G of x moved 1 unit, but where are we moving the unit to? It's a plus 1, so it is moved 1 unit to the left. 1 unit to the left, and we know that it is a horizontal shift because it is affecting the x. If we look at our Cartesian plane, and if you want to, how do you then remember this in a test or an exam? If you look at your Cartesian plane, you have the x-axis and the y-axis and the x-axis here. So any movement that affect x, it's going to be a movement that either moves to the right or to the left, because it is a horizontal line, that x-axis. But a movement that has to do with shifting the graph up or down will then be affecting your y values. So because h of x is now g x plus 1, the transformation is done on x, which means it is either a left or right move. So if we add, we are moving to the left, and when we subtract, we're moving to the right. That is the golden rule. So h of x is just our g of x function, but moved 1 unit to the left. Okay, so let's just first get how the new equation will look like. Now 4.6, we say h of x is equals to g x plus 1. We know that our g of x is given by 1 over x minus 1 plus a 2. This was just g of x, right? So when we have h of x, which is g x plus 1, it means instead of just having x, we'll have x plus 1. That's what we would substitute. H of x is then your g of x as it is, but plus 1. So you'd have 1. And wherever I see x now, it will be x plus 1 here. Then I'll still have the minus 1. Let me just make this red so it shows the x plus 1 that's been added. And we still have that minus 1 from the formula plus 2. So then my h of x is just 1 over x plus 2. And this makes sense because our original function looked like this, where our asymptote was x is equals to 1. Now, if we shift to the left, we actually are moving this x equals to 1 to this line, where then your x is equals to 0 as the new asymptote, because we've shifted 1 unit to the left. Okay, so this means your new asymptote here is what? X is equals to 0, because this is the same as plus 0. Right, meaning that your P is a 0. This is then your new vertical asymptote. But the question asked for the domain. So our domain is all the possible x values. We know this will be x is an element of real numbers, but x should not be 0, because at x is equals to 0, it is our asymptote. Right, thank you very much, guys. I hope to catch you on the next videos.